So I wanted to talk a little bit about the two-post lifts that we use in labs, and there's a few of these labs where you would rack cars up, and so I want to give you a few guidelines for racking your vehicles up. When you're using these two-post lifts, super common to use in a shop, you're either typically going to rack vehicles up from the pinch welds, which I'll insert a picture of the pinch welds on a car, or you're going to grab them from the frame. We can grab them from things like the stub frame, or in other cases you can grab the shackle where the leaf spring would mount. But there's a couple general safety guidelines that you want to follow when you're using a lift. Once you get your lift point set and you get the car about 6 inches off the ground, shake it well, because if it's going to fall, you want it to fall while it's right off the ground. You're not going to hurt the car, you're not going to hurt yourself. So make sure that you shake the car. If you hear any of the lifts clacking or rattling, then that car may not be balanced well. A story that I often share in the intro class when we talk about lifts is when the first shop that I worked at was a tire shop, a mechanic shop, and then a truck shop, so like semi-truck. I had 3 different areas going all at once, and across the way from where I worked in the mechanic shop, across the way was the tire shop, and they got a extended cab, or really it was a crew cab long bed dually Ford truck, which some of you guys have seen some of those they're a super long truck. And they got it up on a 2-post lift. They never shook the truck, and they went to rotate the tires. They took one front tire off, and when they took the second front tire off, the truck tipped over backwards and fell off the lift. So it's important to shake these cars before you get underneath them. Shake them before you get them 6 feet up in the air and make sure they're balanced. Simple controls on this. There's a button that controls the hydraulics. It'll raise the arms up. This bleeds the hydraulics off, and then the red handle over here is the mechanical lock. So once you get it a few inches up off the ground, the arms will stop swinging. So they're going to lock into place with some little pedestal locks right here on the back side. Couple of rules: when you can lift from any part of this arm. I can lift from here. These will slide in and out to set adjustment depths. These flip up and down. You got a 6-inch and like a 2-inch or 3-inch pedestal, or you can lift them flat, and like I say, any portion on that arm. But when you are flipping these pedestals up, the rule that you want to follow is that you always make a V like this side is, or you always make an A out of these pedestal arms, because we don't want to domino them. So if this one, they're opposed to each other, where if I had them flipped the same way, then they would domino down the same direction. And so always flip them to where they're opposed to each other in a V configuration like this, or an A configuration there, for safety. There's little attachments and extensions that do fit over these for different vehicles. We have these of different lengths, but these would slide over. Typically, I'll move it to where we would usually use it on the back, and they'll fit into place to give you different purchase. We want to try to lift cars up as level as we can, but if they're not perfectly level, it's not the end of the world, as long as they're secure. This I often use on the BMWs as a pad to grab some of their lift points, or sometimes we'll use it on a lowered car that we'll have to jack the car up and set it on the lift. But different attachments that we have there. A couple of things that I want to bring your attention to. So always going to use the A or V configuration on that. Now, as I lift this vehicle up, you're going to start to hear the mechanical locks engage. The mechanical locks are behind here. There's a lock there, and there's another lock behind this cover here. You're going to start to hear them clack and engage. So I'm going to go ahead and lift this up and do that. So there they go. So notice it's pretty high up in the air before the first mechanical latch started to engage. So there may be times where you have a car a little bit up off the ground before the mechanical latch engages. You may be tempted to get on a creeper and roll underneath that car. What I would want you to do in that case for your own safety is to put a jack stand under the arm. So you put a jack stand in under the arm, because if the hydraulics fail, these lifts will drop to the ground. So to protect yourself, you want to put a jack stand under there so that if the hydraulics failed on the lift, that it would not come down on top of you if you're not on the mechanical locks. When we lift something up to the height that we want it to be, then you're going to always bleed the hydraulics off and set it on that mechanical lock. So these will stop on those mechanical locks there. So now you're not relying on the hydraulics of the lift anymore to support or secure the vehicle. And so once you get it up to the height you want, set it back down on the mechanical locks. Couple of things that does, that preserves the lift, that keeps any stress and strain off of the lift, and then also is safe to ensure that you're on the mechanical locks, that if the lift were to fail, that it would not come down on top of you. Then when you need to lower it, you'll raise it up off of the mechanical lock. You're going to release your locks here and then bleed off the hydraulics, and it'll come down. When you have the weight of a car on this, it's going to come down quite a bit faster than what you're seeing here when you got several thousand pounds on there. But that's your general lift safety. Those arms swing in and out. We can grab vehicles from the frame, from pinch welds, and then we're going to rack a vehicle up, coming up in multiple labs, but coming up on the brake lab that we'll do next. But I'll get some pictures of where we lifted that from, and then I'll also throw some pictures in of where we rack them from the pinch welds. So once we get this all the way down on the ground, then those arms will swing again. So now these will move. They're not locked. This lift too, I should say, is an ISO lift. So you'll notice that the poles of this lift are angled back. That helps if you're getting in and out of the car. It kind of sets the doors back to where the majority of the car is back behind this lift, to where you can get in and out of the doors a little easier. So now we got the vehicle positioned and pulled up onto the lift pad. That lift pad there is kind of a general guideline of where to place the tire. You want to try to pull the vehicles in where they're pretty centered in between the two arms of this two posts, or the two posts of this two-post lift. So we're going to swing in and grab the front and grab the rear. So on the front, I'm going to be on the small pedestal, and I'm just going to grab the frame. Set this back one. Take it back. I think I can clear the tall pedestal, so I'm going to use that. Maybe wrong. Sometimes you can lift up on the fender a little bit like that, position where you want. Now we'll set the other side. So, once you get your lift arm set, you want to try to be as far forward as you can and as far back as you can, so you get as much purchase on that vehicle as you can. Then you want to raise it up and double check your contact points, and then shake the car. So listen for any funny noises. Make sure it doesn't feel like it wants to tip over off the back. So once I'm happy that it's secure, then I feel safe to lift it up to whatever height that I want to work at. So this is lab 11 for your brake system inspection. A brake inspection should be performed with any type of brake work that you do so that when you quote a customer, you know exactly what they need. We want to evaluate the condition of the brake system before we start quoting any type of repair work so that we have a complete picture. It's also typical that the type of stuff that we look at for any type of brake system diagnosis. Generally, when we do a brake inspection, we're going to start out with a test drive. The test drive part of it is not something that we do in this lab just given the situation here at the college, but when you're working out at the shop, you're going to want to do a test drive initially before you get anything apart. And a couple of things that will do is that's going to key you in to the type of problems that car already has. And then there's some of the things that we want to be able to effectively evaluate on our test drive. And so while you're on your test drive, few things that you're going to want to pay attention to is you want to pay attention to the pedal height and the feel. So I want you to use your own cars as a gauge for what normal is. So how far does your pedal travel? How does it feel? You've been driving long enough to know what normal is. If you have a pedal that sinks all the way to the floor, you have a problem. If you have a pedal that's all the way up at the top and super tight, then you know that that's not normal. Normal pedal height and free play should be 1 to 2 inches down from the top before the pedal starts to get firm. And so we should have a little bit of free play in the pedal before we start having brake application. And that's because we don't want to be right on the cusp of applying the brakes. We want to make sure that the brakes can release when we let up off of the brake pedal. And so we also want to pay attention to whether the brakes grab. Grabbing is like if you barely touch the brake and then it wants to lock the wheels up. That would be grabbing brakes. Or do they pull to the right or to the left? Is the pedal extremely low? And things like that when we're applying the brake. To check for brake pulsation, the recommendation, what I generally did, is I would get the vehicle up to about 50 miles per hour and then I would start to lightly touch the brake. And if you lightly touch the brake, if you feel the pedal come back and start hitting your foot, then that's an indication that the rotors are warped. We'll also listen for noises. So if the Lord blessed you with big old ears like mine, then I'll stick my head out the window and I'll apply the brakes and listen if I feel like I hear it from the front or from the rear or things like that, right or left as you're driving. Another kind of useful thing in that regard is I found that driving next to a wall will kind of echo those noises back to you. And so that's useful for helping to find noises. In addition, you want to see how well the car stops. So I have a note on here about brake performance. Does the car stop well, or does it seem like it takes excessively long to stop? But those are the types of things that we pay attention to. In addition, if you have a customer that has any particular problem that they're wanting you to diagnose, then obviously you go after that and pay attention to that and get a baseline for how this vehicle's brake system operates. To begin on this initial inspection that's in your lab book, there's a few things that I just want to explain verbally. And so the pedal height and feel and free play we already talked about. But brake lights and warning lights. The normal operation for your red brake light and your ABS light is that when you turn the key on, they should light. And then when you start the car, they should go out. That would be normal function for a brake light or an ABS warning light, and pretty much all warning lights for that matter. When you first turn the key on, they should light or be on. When you start it, they should go out. And that would be functioning properly. If it doesn't light when you turn the key on, that's a problem. If it stays on after you start the car, that also indicates a problem. And keep in mind that the red brake light will stay lit if the park brake is set. Then brake fluid level and condition and color, master cylinder seal and cap, and then our park brake. So when we take the master cylinder cap off, we always want to pay attention to whether it has splits and cracks, because brake fluid is hygroscopic, which means it attracts water. So we pay attention to that because we don't want our fluid to be contaminated with moisture. There's a test that we'll do that I'll show you you can use test strips, or you can use little electronic testers like this one. And so this one we just dip down into the brake fluid, and then if you hit the button on the top, If it lights up green like that, then the fluid is fine. And then it'll indicate the level percentage-wise of contamination. And so we can do that real quickly. These are pretty cheap. They're from OTC and they work well to be able to test the brake fluid. And then to check our parking brake, the test that I always did is that I would start the car and I'd put the vehicle in gear and set the parking brake, and then see if the parking brake can hold the vehicle. And so that works well for your automatic transmission. So set the park brake, start it, put it in drive, put it in reverse, can it hold the car? That's a sufficient test. The official DOT test is to put it on a 7% incline and set the brake and see if it'll hold. We don't have the ability really to do that typically. That even when I did brake and lamp inspections for the state, when I would do a test of the parking brake, that's what the general accepted procedure is for the industry. Of course, if you have a manual transmission, then you get to kind of use your judgment. How well does it stop? Does it seem that it's effective or not? But it's super easy, and a lot of cars are automatics that just set the park brake, put it in gear. As far as checking our master cylinder cap, if I take the cap off of here, I want to make sure that the fluid level is full. And I should say this, a lot of times when you take these caps off like this one, the seal will come out. When you're putting it back in, make sure that you put the seal back in the cap first before you try to install it. And so if I take my little brake fluid tester, we'll see what results we get here. So this one lights up as contaminated all the way through to the top. So this one, which is typical for older cars. And so this would be one that we would recommend a brake fluid flush. The condition of this fluid, if you look at it as well, it's really dark and oxidized, and then also it darkens up from getting brake dust in it. And so I want you to consider how and where it gets the brake dust. And so understand that the fluid travels all the way out from the wheel assemblies all the way back up to the master cylinder. When we press the brake, we're moving fluid. And so it eventually will mix its way all the way back up to the master cylinder, that as brake dust gets by the seals out at our wheel assemblies, whether it's calipers or wheel cylinders, it'll get into the fluid and work its way all the way back up to the master cylinder. And so that's why it's significant. If you ever saw a seal that was swollen and from being contaminated by a petroleum product, people often make the mistake and put power steering fluid in their brake fluid master cylinder, and that'll contaminate it with a petroleum product. The brake fluid seals are all water compatible, and oil compatible seals or rubber components and water compatible seals are two different types of rubber. And so if you get oil in the brake system, it makes all the seals swell. And so even though they're adding it at the master cylinder, we have to replace every single brake system component that has rubber in it to be able to ensure that that vehicle can safely be put back into service without being at risk of a failure. And so it's a very costly mistake if a customer ever does that. So make sure you never do that. You pay attention, have your head in the game, and make sure that you never add power steering fluid or some other oil product to the brake system, because you'll ruin it. And so our first indication that somebody has ever contaminated the brake system is that the seal at the master cylinder will be swollen. It would be hard to put back in the cap. And then a lot of times too, the complaint you get when somebody has done that is that they'll complain that their pedal feels really hard, or that the car stops on its own, or things like that. And so we can usually pick up on that by inspecting those seals. So this one has contaminated brake fluid, and it's contaminated by moisture is what we're looking for. That's what that tool does. It's not checking for petroleum product contamination. We visually find that typically by swollen seals. Good enough on any of that. And so we'll go ahead and raise the car up and start removing the wheels here. So set it back down on the locks. In case you're wondering, I already did shake this car. to make sure that it was balanced and secure. So we'll go ahead and get our wheels removed off of this. And so you're going to want to pull all four wheels to do your inspection. This just has a little plastic beauty ring. I usually like to set the lug nuts up on the post. Don't set them on the floor where they get kicked all around the shop. My old boss would literally kick the lug nuts if you left stuff on the floor. So it's a bad habit to set stuff on the car or to set stuff on the floor where you're going to lose it. So we'll take the drum off of the back, and you do all four wheels. I've only got the front done here. But now we're going to go ahead and make an inspection of a few different things. We're going to inspect all of our hydraulic system for leaks. We're going to take measurements of our rotors and our drums to make sure that they're within specifications, that they could be machined or that they're safe to be in service. And then we'll take a measurement of our linings. And so I'll address a couple of things here. With linings, we never give a customer a mileage estimate for how long they can drive, because you don't know how they drive. Some people drive like maniacs. I had some customers that could wear out a set of pads in 9 months. Had others that would go years on their same set of brake pads or shoes because they took it easy on their car. They coasted up to stop signs, and you've seen some of the other people that are always on the gas and jamming on the brakes and then taking off again. It'd give you whiplash to drive around with them, make my kid's car sick. And so people that drive their vehicles harder will go through brakes sooner than people that kind of baby their car. And so with that, we can never give them a mileage estimate. We can only give them a percentage of brake friction lining that they have left, or pad material or shoe material. Are they at 70% or 50% or 10%? We can give them a percentage, or we can just tell them how thick they are. And we typically do that just in millimeters. And so in addition to that, I want to take a little bit of time to talk about inspecting our brake system drums and rotors. So the reason why there's a minimum thickness on a rotor, so we take material off and it gets thinner and thinner and thinner. There's a minimum thickness because really there's only so far that brake caliper piston could come out before it would pop the piston out of the caliper. We also need we say that, or we've talked about in class that the friction generates heat, and we have to be able to get rid of heat so that we don't overheat our friction lining materials and cause brake fade and things like that. Well, the brake rotor and the drum are a heat sink, and so they absorb heat and help us dissipate heat. And so when they get thin, they lose enough material that they become more likely to warp, and then they're not effective as a heat sink to be able to absorb heat from our brake systems and dissipate it. And so for a rotor, there's a minimum thickness that once we've removed enough material, then it hits its discard thickness where we get rid of it or throw it away. And for a drum, they hit a maximum diameter, and it relates back to a mechanical condition, just like with a rotor, a disc brake system, that the shoes can only come out so far, that if the diameter of the drum gets so big that we don't make effective mechanical contact with the drum, and so it would be discarded for that reason, and also because it would not be effective as a heat sink. So we'll go ahead and look at these disc brakes and drum brakes individually and talk about a few things there, and then take some measurements, and then we'll go ahead and move on from here. So this is just a close-up view of our disc brake system with the wheel removed. We've got our caliper here. This little pin across there is a slide. So on here we've got our slide pin across there, the caliper, and then the pads are on the inside. So we can see a little bit of the backing plate of the pad there, or down below we can see our pad and our backing plate there, and then our slide pin. Then we've got our rotor, and then on the back end, just kind of here, is a backing plate. They often get bent during brake work, so I always will make sure that that they're not touching the rotor. So if we turn the rotor, you can often hear the backing plate drag if it was touching. It's kind of a rookie mistake. You always want to watch out for that. That you have a tendency to like lower the car or pry on something, you'll get that bent where it's touching. It's a relatively common kind of rookie mistake to make. So watch out and inspect for those backing plates. To inspect our lining thickness, we're going to use a little thickness gauge like this. So this is just a simple brake lining thickness gauge. Green is good, yellow's marginal, and red would be bad as a general rule. And so, like I mentioned, we're not going to give mileage estimates for how long somebody has on their brake pads or on their brakes. We'll only tell them how thick it is or give them a percentage. Now, in order to give them a percentage, you have to know how thick new is. So if we were 10 millimeters new and I measured 7 millimeters, then they still have 70% of the lining left. Some manufacturers will give you a spec for the lining thickness new when we look it up in Mitchell or ALLDATA, so that's where you would find that. I just want to make sure that you understand that this is just a general guideline. So some of the manufacturers like Nissan, their pads will come at about 7 millimeters brand new. And so you may look at them and measure 3 millimeters or 4 millimeters and go, oh crap, it needs a brake job. We're into the red at 3 millimeters. Well, in reality, if it came at 7 millimeters new, then we're still at 50% of the, not 50 quite, but 40% or better of the friction lining left. And so you'd be overselling that brake job to sell them a brake job when a Nissan that started at 7 was at 3 millimeters. So keep that sort of stuff in mind. And if you ever make that mistake with a customer, then just be honest. Be like, well, I pulled the new ones out of the box and they weren't that much thicker than the ones you had on. I've had to do that before, and you kind of learn to be careful which manufacturers start pretty thin. These start really thick. What we're going to do with this gauge is you don't have to take anything apart. A brake inspection should be relatively quick. And so what we're going to do with this gauge is we're going to run it in and run it up next in between the backing plate our backing plate for our pad there and the lining, and then we're just going to gauge it roughly on how thick they are. So like this one is right in there. If we look at this is 10 millimeters. So what you'll do is find windows in here to measure this. And so on this one, and then write down your thinnest one. And so on this one, if I come in here and measure that one's at 10. This inside one, a little harder to get a gauge on. Yeah, this one's at 10 for both. So we would want to see even thickness side to side. And so if you ever had one that was, 10 millimeters on the outside one and 7 millimeters on the inside, then they're not wearing evenly. They'll start out the same thickness when they're new. And like we talked about in the classroom lecture, that can be the slides that are gummed up. That can also be a piston seal that got hard, your square cut seal that's not retracting the piston in the caliper. So a couple of other things to pay attention to. This one, just as an example, it went metal on metal here, but you can see that it still has some thickness here. So we want to make sure that top to bottom on these pads that they're wearing evenly. This is extremely exaggerated, but I don't have a better one to show you. But if it had thicker material here and less over here, then generally what's happening is that on the mounting for this caliper, not only does the caliper need to slide, but the pads also need to slide. And so if we have the slides that get dry or rusted, then sometimes they'll hang on one side and they'll start to drag even though the piston is retracting. And so that can give you some kind of tapered wear on these pads. The The other thing that we look at is just for leaks in general. So there's a rubber line that comes over here so that when our suspension travels up and down or the wheel turns side to side, we can have a movable connection with that rubber line. The rubber line, we look for leaks there, look for leaks at your caliper. Now, calipers, wheel cylinders, things like that, they can only leak externally. If there was a leak here, this would be wet with brake fluid. If that brake fluid got on the pads, then we end up replacing them for that reason. So you look for fluid contamination on your pads as well. On a rear axle, it's common for axle seals to leak and get gear oil on the pads or the shoes. And so we look for fluid contamination on those pads and linings. So calipers can only leak externally, lines, things like that. A master cylinder or an ABS unit can leak internally, where they bypass the seals within itself. But a caliper, we're looking for any external leaks. The other thing that I want to address with you, as a general part of our inspection, the bleeder for this should always be up at the top. And so our bleeder is up over here at the top on this configuration. I've had customers come in that did work at their house where they had the bleeder down below and they came in because they couldn't get the air out of the system. The lines like this for our calipers, you never want to leave them hanging when you're doing brake work. You support them and I'll either hang them up like that or I'll get a hook and I'll hang them off to the side. These rubber lines are ribbed, and so that's so that we can tell if they're twisted. So this caliper in this truck has a really short rubber line, so it'd be pretty hard to twist this one. But one that has a long line like this, you could install this with a twist like that. And so that's one of the things that we'll look for, another kind of rookie mistake. But people will get in a hurry and they'll install them with a twist. Well, when this wheel turns, it's going to pull and it could jam this up and pinch the line or rip it off. And so watch your brake lines, make sure they're not twisted. That's another common thing that people do. So they should go like this, but when they go and install them, if they're not paying attention, then they'll kind of roll them up like that and put a kink or a twist in it. So one of the other things that I want you to see as well is that if I turn the steering wheel back the other way, then oftentimes on the rotor itself or on a drum, they'll mark the minimum thickness. And so if we look on here, it says minimum thickness right there. So it says minimum thick, it's MINTHK. So minimum thickness, and then over here, it says 24.5. So 24.5 is not inches, that would be millimeters. And so we'll grab a brake caliper and then we're going to take a measurement across here. So we just want to measure general thickness here. The other measurements that you can take for warped rotors, and you should, is either run out where you touch a dial indicator off to the face and you rotate this and it'll show you how much run out is in the face of this rotor and if it's warped. The other inspection that we can do that's not necessarily part of this lab, but we can take a measurement that's called parallelism, where I take a measurement here, there, and there in 4 different spots, or just multiple spots in general, and you make sure you get the same thickness everywhere you go, and that would tell you that that rotor doesn't have thickness variation. So that's how you would inspect for warped rotors, is either a parallelism check or run out with a dial indicator. We're just gonna, to see that it's in tolerance for safe use, we'll take a thickness measurement here. So our spec is 24.5. We can just use a regular digital caliper here and take a measurement. So what I like about digital calipers, they have batteries, which is subject to having batteries go dead. But with a caliper, I can switch it from inches to millimeters really quickly and easily. Same with all of our precision measuring tools. Wipe your measuring faces, close it down. We're gonna turn it on. Right now it's in inches, so I can just switch modes at the press of a button and move it to millimeters. Make sure it reads 0. If it doesn't, then you can always 0 it back out. And then we'll find a spot where we can slip this in. you'll notice that on these jaws, it's got a cutout towards the back. There's often a lip on the edge of a rotor, so I want to make sure that I insert this deep enough to where I don't measure the lip and I make contact with the face of this rotor. So I'm going to come in there, make contact. I'm at 26.32 millimeters. So our spec is, the minimum is 24.5, so this one's in good shape. Well, these rotors would be able to be machined. Generally, when you resurface rotors or drums, you're going to take about 5 to 10 thousandths off in a first pass. So I like to account for about 15 to 20 thousandths that I need to be able to machine. If I'm within that, then I would consider that good, to where I'm not too close to the minimum thickness by the time I get done. I can't be under by the time I get done machining. If I machine them and resurface these rotors on a brake lathe, then we're going to make sure that we always wash them with soap and water. That demagnetizes the little metal shavings that'll build up. If you don't do that, those will embed in your brand new brake pads or shoes, and then it'll make brake squeaks. We're also going to inspect this rotor to make sure it doesn't have any hot spots or surface cracks, huge gouges or grooves. I don't see any issues there, so it's within specs for a thickness, no hot spots. It's common to get some discoloring on these because they get hot, but I don't want to see these blued blotches throughout here or cracks across it. So on this drum, we're going to take a measurement of the friction linings. These are shoes. So our brake shoes, we have got a backing plate for this drum, the hydraulic components, a wheel cylinder. We've got some return springs and hold down springs that are in there. Make sure that none of these are broke and that this isn't loose. And then the rest of this is for just measuring linings. There's a couple different ways. And so on this one, they make bonded linings that are just glued on to the anchor, or not the anchor, but the frame of this shoe, that are just glued on, and they have some that are riveted. And so this one happens to be a riveted one, and so I want to show you the difference. If we just take our thickness gauge and we match this up on the outside, that's 6 millimeters. We'll see what the next size up is 8. So 8's a little bit big. 6 millimeters is a tick small, so I count that as 7. And you want to make sure, or actually we're at 6 up here, so we're fine there. You want to take your smallest one. And if we come over here to this side, then 6 is already too big. And so now we're at 5 over here. And so write down your smallest number. So 5 millimeters is what we have left, but I want to show you the difference. So on a riveted shoe, or pad for that matter, this may measure out right now at 5. If I use just a tire tread depth gauge, I'm getting on millimeters, I'm getting 5. But if I go to the rivet, which is what would actually touch first, then in millimeters I actually get 3. So there's 2 millimeters of rivet on there, so in reality, if I get 3 here, if I'm getting 3 here, 3 is what I actually have. So I've got 2 millimeters of rivet there. So I got 3 millimeters till these touch off. These are relatively new. This one also is a servo style of brake. Right, so we would see that we've got a lot of lining back here on our secondary and our primary towards the front. So servo brake system. So this one's going to engage first and then help apply that secondary. And so that's what you would write down, is they've got 3 millimeters left. The reality is, on this style of brake system, these are still in pretty good shape. These are probably at 60% or better. And so then we want to inspect our wheel cylinder. This is another... on this one, what we're really looking for is we've got a dust seal, all right? So you got a dust seal on your wheel cylinder that would be like this. Really what we're trying to see is if this seal on the inside, which this is a cutaway of a wheel cylinder, but if this seal on the inside has failed, and if it has, then I'll get brake fluid out into the dust seal. Now, generally, what we'll do is peel back the dust seal and see if there's any brake fluid there. If there is, then you recommend replacing wheel cylinders, and you'd sell them in a set. Same way with calipers on a disc brake system. If one's bad, you sell both, because they're basically right behind each other. Whatever made that one go bad, the other one will do it typically soon after. So you'd sell them both. If you get one wheel cylinder that's leaking, you sell both. Now, pay attention to wetness in here. This is where inspecting fluids and stuff like that and knowing what they smell like, what they look like, comes in handy. Because on a drive axle like this is the end of our drive axle. If that seal goes bad, it'll leak gear oil all over these. And so if it's gear oil, it'll smell sulfury, and you can smell it. So you would touch and make sure and see what it smells like. This one is wet inside here. And so it does not smell like gear oil. But to inspect this wheel cylinder, you're going to just grab a screwdriver. Now, what I'm going to do is I'm going to run the screwdriver up in that one and get past the little pin that's in here and see if my screwdriver comes up wet. So I'll run it up through the hole there and kind of get past the dust seal, because this one has internal seals. So these ones, the dust seal is external where I could peel it off and look at it. A lot of wheel cylinders will be like that. If you ever get one that is inserted or recessed inside, then you're going to want to stick a screwdriver, typically a pocket screwdriver or a small screwdriver in there. And so we'll do it to both sides. So I'm just going to run this up in here and see if I get brake fluid. And you can see that that is wet, and so that wheel cylinder is leaking. And we can see that it's already wet on the outside. And as I run this up in there, I'm already getting brake fluid. And so this wheel cylinder is bad. While I have you here, I'm going to show, or while I have this set up here, I'm going to show you one other thing. So we've got lining thickness that we're going to inspect for springs. Look at your wheel cylinder hydraulic component, make sure it's not leaking. Make sure you don't see any damage. Metal dust inside here would indicate a problem. You can also check your adjustment of your drum as well and make sure that it's not super loose. But one of the things that I wanted to show you is just these little brake tools. These little spring tools, this is supposed to be used to kind of grip the outside of here and help you install springs. I never use this part of the tool, but I love this part. So just a little quick tip on doing rear brakes. If you're doing rear brakes, do one side at a time, because if you screw up one side, you can always look at the other side and see how it goes back together. A lot of people get confused on doing drum brakes, but with this tool, I can run it over my anchor pin and pop the pin off. So this runs up in between the spring over the anchor pin and pops the spring off. And so that's a good use for this little tool. I love that. But when I install the spring back on, some of you that have done this before will watch this. If you don't know this trick, then it'll make your life a lot easier. But if I just hook a screwdriver and hook the spring, then I can slide this up into place, piece of cake, with a screwdriver. So that's your little trick for doing your drum brakes there. So we'll go ahead and measure our drum now and make sure that it's within specs. But the brake inspection here, lining thickness, take our measurement there. You can do it with your thickness gauge or even with just a tire tread depth gauge to get millimeters there. And then you can take that to the customer to let them know how much is left. Always compare it to what they come new if you're going to give a percentage. And make sure you understand how thick they come new so that you can make good recommendations and honest recommendations to your customers. So this one, wheel cylinder's leaking. And it's got brake fluid coming internally that's making its way out to the dust seals. So once it's done that, then it's made it past the internal seal. That wheel cylinder is no good. So just like we had with our brake rotor, this drum has the specification marked on it, but in this case it's a maximum diameter, not a minimum thickness like we had for a rotor. But it has listed out our maximum diameter of 9.59. Now that should be, we want to go to 3 digits when we're in inches, which that's 9 inches, 590 thousandths. So that should be 9.590. So that would be our maximum diameter. So on a drum, as we machine material off, the diameter is going to get larger. And on a rotor, as we machine material off, it's going to get thinner. So for this, We're gonna just inspect for surface cracks. Don't see any surface cracks, don't see any hot spots or bluing of this. So no issues there. We'll take a measurement. We would expect that if this drum is in good shape that we would be less than 9.590. So with this is a digital caliper, and so this drum caliper makes it nice and easy. We can switch back and forth between inches and millimeters for your specs that are in metric or in standard. They also make a drum micrometer for doing this type of work too, but you'll learn how to use that one in the brakes class. We'll do what's easy in this class. And so we'll go ahead and make sure that this zeroes out, and then we'll come in and take our reading. So we want to make sure that you're nice and square here. So on our reading here, I'm getting 9.376. So make sure that it's nice and square. Yep, 9.376. So rotate it a little bit, make sure I don't get anything bigger. So 9.376 is well under the specification of 9.390, right? So 9.376. So in that case, then we have enough material to be able to machine this. I'll have you do the calculation on how much is left. One of the little tips that I always point out in class that I want to make sure that you're aware of. When I would measure rotors and drums, when they're new, the lip right here, right on the edge or the cusp of the opening of the drum, or right on the edge of the rotor itself, where we would machine the surface, if it has a little chamfered edge, which this one does, I'll get a close-up picture of this chamfered edge for you. But if that chamfered edge is still there, then generally there's still material left to be machined. I always still measure them, but when I see that little chamfered edge there, it's usually an indicator that when I measure it, it's going to come out good. So the last part I want to demo to you is the rest of the hydraulic system inspection. This truck happens to be real compact and self-contained, but we'll look over for leaks. Master cylinders and ABS units like this are two of the only things on a brake system that can leak internally. And so when they do leak internally, one of the situation that you'll feel is the pedal will either sink to the floor as you're applying the brakes as it leaks internally, or the pedal is real low. So we talked about dual master cylinders in our brake system lecture, and they have two separate pistons that if one of the piston seals fails, then the other mechanically touches the other. That produces a low pedal. When the seals bypass as they slowly leak internally, then you'll apply the brakes and they'll slowly sink to the floor. You can also have complete failure where you hit the brakes and the pedal goes all the way to the floor. Now, if you have any external fluid leaks, then that would explain that, right? Fluid dripping on the floor, you've got an external leak. But if you go over and inspect a vehicle and there's no external leaks anywhere, then it could be leaking internally from either the master cylinder or an ABS unit. Now, the external leaks on a master cylinder usually leak down the front of the booster, and so a lot of boosters may be painted from the factory, and so it'll orange peel the paint up on those, so we always look for that. Low fluid level can be an indication of a leak, or it can be an indication of just low friction linings on a disc brake system. So that's also addressed in your book, that if as the linings wear and the piston has to chase the linings out, then the void behind it gets filled with brake fluid and the level in the master cylinder goes down. So we're literally looking for wet places on your ABS unit here, your master cylinder, or any of the other control valves. Follow the lines with a flashlight and look for any external leaks there. Splits and cracks on any of your rubber hoses. There'll be some on your independent suspensions like we had up front here. There'll be a rubber line attaching to each caliper. And then on the back end, because that diff can move up and down, there'll be a rubber line back there to inspect. I always look them over like any rubber, make sure no splits and cracks and no external leaks. But that wraps up our brake inspection.